Hi everybody, welcome back. It's Mr. Reneker again. In today's lesson, we are going to be talking about linear functions. We have a lot of experience already with scenarios from our previous chapters. So after a few examples, you should realize how much strength you already have in this area. Let's get into it. All right, first things first. A linear function is just a function whose graph is a non-vertical line. A linear function can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. So a lot of that we already have experience with some of those ideas. For example, y equals mx plus b here is just our slope-intercept form. But there is this extra little bit about it being a non-vertical line. Now, in our work previously with linear equations and slope, we know that slope can be a positive value, it can be a negative value, it can be zero, or it can be undefined. So that undefined is when you would get that vertical line that we've seen in the past. But in order for something to be a function, remember that every input can only have one output, but a vertical line would ruin that. An input would have an infinite amount of outputs, which is why we can't have them since we are talking again about functions. So with those thoughts in mind, let's talk about today's objectives. We've got two main things that we're going to achieve in this lesson. And your first objective is going to be simply to write a linear function specifically from a graph. Again, we're going to borrow some skills from linear equations before. Your second objective is going to be to write a linear function, again, specifically from a table of values. Okay, so those two things you should be able to do with linear functions by the time we're done. Let's go ahead and get into example one. Okay, so in example one, we're going to start with our first objective, which is writing a linear function using a graph specifically. So again, a linear function, ladies and gentlemen, is just going to be basically a linear equation as long as the line isn't vertical, which is predominantly what we'll see here. Okay, so in order for us to write a linear function, we're going to have to relate y and x. Now, when we think about linear scenarios, we already know about a relationship between y and x. Specifically, what I'm talking about is slope. You might remember that slope, which we define using the letter m, can be found by relating y to x, specifically a change in y over a change in x. That ratio right there is always going to provide us with slope, or that rise over run idea from chapters past. We also might remember that to find the y change and x change, we can use any 2 points that are on a line, and we see here that we've actually got 4 different points to choose from. So you guys are going to want to choose the values that you think make the most sense for you. Any 2 again will work. So I'm going to go ahead, I'm going to choose 0.43 up here and then 20, simply for no other reason than those are my personal preference. If you guys are following along, you could try it with 2 different points. I'm going to find the y change, and my values would be, let's see, 3 and 0, so I'm going to find the difference or the change between them, and then the x change would be 4 minus 2. Once I do that, I see that I have a slope of 3 halves, and that'll be the first part for me writing my function. Now, a lot of the time here in our lessons, you are going to see functions still written as y equals, but keep in mind that functions can also be written as f of x equals, and ultimately for our intents and purposes right now, they are the same. Okay, so to start writing our function, we have to think about what we know about linear scenarios. We know that they have a slope, or m, and typically that format ends up being y equals mx plus b. Again, that slope-intercept I mentioned a little while ago. Well, we already have our m, so we know the function will read y equals 3 halves x. But then we have to also look at b, which you might remember is the y-intercept. Thankfully, on most graphs, not all, but most, it's pretty easy to identify the y-intercept visually, or the place where the line will cross the y-axis. And here we can see that it's at that point 0, -3. Of course, we're most concerned with that y value, so we know now that our y-intercept itself is -3. So to finish out our function, we would have y equals 3 halves x plus -3, or of course you could do -3 instead. That means the same thing. So writing a linear function using a graph is going to be, again, nearly identical to writing a linear equation from a graph. Just that last little piece is, again, the line can't be vertical. All right, let's go ahead and take a look at example 2. Okay, in example 2, we'll hit on our second objective, which is writing a linear function using a table. So to use the table, again, we'll relate y to x, which means we are going to be looking at each one of these columns in this case, and realizing that we have another set of ordered pairs. So what we could do first is go ahead and get a coordinate plane and plot these ordered pairs to see what this actually looks like. Plotting these ordered pairs would give us a graph that looks something like this, and you can tell pretty quickly that these points are indeed on a line together, which means we could go ahead and start to tackle this problem like we would any other linear scenario. We're shooting for that same format of y equals mx plus b, of course meaning that we need to find m and b, or slope and y-intercept. We only need 2 points to find slope. We have 4, so we have more than enough, so we can go ahead and start with that first. I'm going to go ahead and choose just the first 2 points up here, just for consistency's sake. Folks, make sure that you're making wise choices when you choose the points you'd like to use to find slope. I'll use y change and x change to discover that slope. My y change being 7 minus 9, the x change being -2 minus -3, and that leaves me with -2 over +1, which makes my final slope -2. All right, I've got the first part. Next, of course, we are looking for that y-intercept. Again, in this situation, it looks like the y-intercept is very obvious. In other situations, maybe you can't see the y-intercept either on the graph or in the table. So just as a quick side note, please keep in mind, folks, that you might have to resort to using point slope form instead of slope intercept form, which looks like this. So just kind of keep that in your back pocket. That would require you, of course, to have the values of one ordered pair. You'd still have to find the slope, but you could use that strategy as well if you need help writing your functions to get going. Besides that, of course, we can see our y-intercept right here on the graph is at 0, 3. But we can also find it in the table, of course, right over here. And we know that that's also the y-intercept because the y-intercept happens when the x value is 0, and that's what we have. So you didn't absolutely have to have the graph to find that, but it is pretty clear now that b had to equal 3. Now that we have both values, we're okay to go ahead and finish writing our function. And we know that we're going to use y equals mx plus b, where in this case m is -2 and b is 3, so our function will read y equals -2x plus 3. So far, it seems that we've hit both of our objectives. We have been able to write a linear function using a graph and now a linear function using a table. We're going to take a look at one more example, though, that's going to ask us to think more about the applications behind some of these linear functions. So in our final example, we're going to be comparing those linear functions. Here we have the following situation. The earnings, y, in dollars, of a nighttime employee working X hours are represented by the linear function y equals 7.5x plus 30. The table shows the earnings of a daytime employee. Right there out of the bat, I do see we have 2 different employees. One works during the day and one at night. Looking at the table, I see that we've got information for 1, 2, 3, and 4 hours of work, and then the amount of money that the person is earning past that. And we'll start with part A, which says which employee has a higher hourly wage. So we're going to have to think about the parts of our situations and our equations and whatnot, and which part represents our hourly wage. So jumping into things, I already have an equation for the nighttime employee, y equals 7.5x plus 30. We're going to take a moment to think about the 2 values that we can explore, our slope and our y-intercept. And in our work in the past, we might remember that a slope, that is typically what we call a rate of change, and sometimes even more specifically, a unit rate. Our y-intercept That's more of a starting point. So, as I'm looking at these two items and they're asking me which employee has a higher hourly wage or the amount of dollars they're paid per hour, I might want to consider which of these items describes that type of change. Is it our slope, our rate of change, or our starting point? Now, before we answer that too much more, we'll also want to look at then our daytime employee. And we see a couple things happening here. We've got some changes happening in the X values. Looks like the amount of time is going up by 1 hour each time. And then we've got some changes in our Y values. And it starts at $12.50 and then goes up to $25, then $37.50, then $50. So it appears to me that the Y changes are going up by $12.50 each time. So I could start the process of writing an equation for the daytime employees as well, seeing as I do have a Y change and an X change, and I know that to find the slope for that person, I can simply write those values in a ratio, and I end up finding out that, well, the slope or the rate of change for the daytime employee is 12.5 or $12.50. Of course, to finish the equation for y equals mx plus b, you'd think, well, I also need to find the y-intercept, and in most scenarios, you'd be absolutely correct. However, part A here, again, simply says which employee has the higher hourly wage, meaning that rate of change, that pay scale that they're on, that's all I'm really concerned with. And as we saw here a moment ago, that's actually going to come from the slope itself. The y-intercept is not going to affect how I answer this question. So when I look at the nighttime employee, I see that they have an hourly wage of 7.5 or $7.50 per hour, whereas what we just found a moment ago for our daytime employee is that they get an hourly wage of $12.50 an hour. So which employee has a higher hourly wage? It is very clearly going to be our daytime employee. Now for part B, they're going to ask us to write a linear function that relates the daytime employees' earnings to the number of hours worked. So they are asking for the official and final function for the daytime employee. And just a moment ago, we did find the slope for that daytime employee, which was 12.5 or $12.50 per hour. And then they're going to ask us to graph both of the functions for the daytime and nighttime employee and interpret what's going on in that graph. So again, for the daytime employee, we already know that our function will start off as y equals 12.5x because we'd already found the slope of that rate of change a little bit ago, but we didn't finish talking about the y-intercept completely. So I'm going to bring back the table to help us look at that. And in the table, unfortunately, we don't have the y-intercept clearly listed because, again, the y-intercept would happen when x is 0. And we don't have that information. But we can use enough of the patterns and the rates of change that we see to help us discover where that would be. What I mean is we already saw a few moments ago the x changes as it goes from left to right. We're adding 1 hour each time. And for the y change, we saw an increase of $12.50 or $12.50 each time. So I already know how those changes are working out. We can use that idea to help us basically go backwards one spot so we will know what happens when x is 0. Of course, that would ask us to use inverse operations. Instead of adding 1 for the x values, we need to subtract 1 because 1 hour minus 1 would give us 0 hours. And we do the same thing for the y values. Instead of adding $12.50, we'll subtract $12.50. And that's where we can then see that actually when x is 0, 12.50 minus another 12.50, that actually leaves us at $0. So at 0 hours, this daytime employee earned $0. Whereas when we think about the nighttime employee, they actually started with some kind of an amount. There must be a nighttime bonus or something along those lines. What that means is that when we go to finish writing our function, and we think about adding on our y-intercept, well, we just discovered that the y-intercept is actually 0, meaning if we were to write plus 0, that would be unnecessary. So our final function is just y equals 12.5x. And finally, they asked us to graph both of the linear functions, the y equals 12.5x and y equals 7.5x plus 30. And to save us a little bit of time, they would end up looking like this. So we can see both graphs here, the nighttime and daytime employee. But when they ask us to interpret the graph, they are asking us to focus on a couple key features. One, what does the slope tell us? Two, what does the y-intercept tell us? And finally, what does the intersection of the two lines tell us? Those are the main things we'll typically focus on. Okay? So when we look at the graphs, what do the slopes tell us? Well, the daytime employee obviously has a steeper slope. Their line is a bit steeper. So what do we know then about the daytime employee? Well, we could say that the daytime employee has a higher hourly wage than the nighttime employee. Next, we look at those y-intercepts, and we can see clearly that the nighttime employee has a higher y-intercept, which means we could say that the nighttime employee has a higher starting bonus or earnings than the daytime employee. Finally, though, we want to talk about the intersection, as that obviously connects the two different functions. We see that the lines intersect when time is at 6 hours and when the earnings is at $75. So what do we know? We know that actually the daytime employee, while they have a higher hourly wage, the daytime employee does not earn more money than the nighttime employee until each person has worked more than 6 hours. It's not until these portions over here that that daytime employee actually does get the benefit of their hourly wage being higher. But that's the last idea for us here in this new section, looking at linear functions. This video is a little bit long. We'll wrap up quickly here with our objectives again. We learned how to write a linear function from a graph and a linear function from a table of values, but ultimately saw that it was very similar to our work with linear equations in the past, as long as the lines aren't vertical. Finally, we got to apply these ideas by comparing linear functions at the end, which you'll be doing a good amount of here in our practice. As always, guys, let me know what questions you have, and I will see you next time.